What the heck?
Tagon.
I'd like to say, what would happen if alpha and beta were the same number, right? So if they were equal, then we would simply be taking the sine and cosine of twice an angle that we know, right? It would just be 2 times alpha if we let alpha and beta be equal to each other. So let's quickly take a look at what are called the double angle formulas, which are simply special cases of what we just proved now. If alpha equals beta, this implies alpha plus beta equals 2 times alpha. So we're going to be finding the trigonometric functions evaluated at double an angle that we know, right? So we know that the sine of 2 times alpha is simply going to be the sine of alpha plus alpha. And all we have to do is plug alpha and alpha into both of the terms in the angle sum formula that we just showed. So we know that this is going to be equal to the sine of alpha times the cosine of alpha plus the cosine of alpha times the sine of alpha. And I only did it in this order, switching these orders, because I wanted the alpha term to come first in the previous one, but now they're both the same, so it doesn't matter. Because multiplication is commutative, I can just flip these, and you see that we just have sine of alpha times cosine of alpha plus sine of alpha times cosine of alpha, which makes the double angle formula for the sine equal to 2 times the sine of alpha times the cosine of alpha. And this is the double angle formula for the sine function, right? If you plug in 2 times an angle that you know, you can evaluate what that is just by using this formula and evaluating the sine and cosine of alpha and then multiplying by 2 and multiplying them all together, right? So this is what you get when alpha and beta are the same number, right? So before we had a more general argument, alpha plus beta as your input. Now we're saying alpha and beta are the same number, so 2 alpha is your input. And if you know the sine and cosine of alpha, you can calculate the sine of 2 alpha. And the same goes for the cosine double angle formula, so let's take a quick look at that. So this still applies, right? If alpha and beta are the same, then this is the same as the angle being 2 alpha. So now we're going to take a look at the cosine of 2 times alpha, which we know to be the cosine of alpha plus alpha. And all we have to do is plug alpha and alpha into our 2 values for the cosine angle sum formula, and we will get the cosine of alpha times the cosine. And remember, we subtract, when this is positive, we subtract in the cosine angle sum formula. We did show that, and it's minus the sine of alpha times the sine of alpha, which means that our double angle formula for cosine is simply the cosine squared of alpha, because it's cosine of alpha times cosine of alpha, minus the sine squared of alpha. And this lovely little formula is the double angle formula for the cosine. And it's kind of funny, this is really close to something we already know, which is cosine squared plus sine squared, which we recall from our Pythagorean identities, that this is actually just equal to 1, right? But if we subtract them, we get the cosine of our doubled angle, which is really interesting.